One of the applications that we're really going to use radians for is finding arc length and area of given sectors. Each of the formulas for arc length and area of sectors requires that our units be in radians in order to use our formula. So first of all, right here I've put up the formal definition of what a radian is. So if we read through it, it says the radian is the measure theta of our central angle, and it's equal to the ratio of the length of the arc, we're going to call that arc here S, and the radius of the circle. The reason I put that on there is because here's what we're going to be looking at right now. We're going to use some time in this video to look at how do I find the arc length? How do I find that length that subtends our central angle? Well, we find it by just rearranging this formula here. If I multiply both sides by r, I get arc length S is equal to r times theta. And again, theta must be in radians. So I want to look at two examples with arc length, and then I'm going to introduce the area formula for you, and then we're going to look at one example with that. So on each of these examples, I'm asking you to round to the nearest tenth. I'm going to show you how to find the answer in its exact form, and then round it at the end, as opposed to rounding at my in-between steps. So I'm asked to find arc length. So first thing I do is I recognize that my arc length is equal to theta times r, where theta is my theta is my central angle in radians, and r is my radius. Well, notice I was given my theta, and I'm going to assume that this is radians, and I know it's radians since there is no unit. Remember, degrees have a unit symbol, radians don't. And my r is 4 inches. So I can go ahead and say that S is pi over 3 times 4, which in exact form is 4 pi over 3. And notice that my unit's going to be in inches. Since radians don't have a unit, one of the reasons why we have to be sure that we're in radians and not degrees, and my 4 has a unit of inches, I end up with just inches. I can use my calculator then to approximate this, so I can round to the nearest tenth, which gives me approximately 4.2 inches. That is going to be the length of the arc. Part B is going to be very similar to Part A. However, notice in Part B, even though I'm still asking for arc length, here I was given a theta in degrees and a diameter in, or excuse me, instead of a radius, a diameter. So I'm still going to use S equals r times theta. So I can find my r very easily. Radius is half of my diameter. And then my theta, I'm going to have to use that concept that we just talked about, or that you just saw, where I'm going to have to say, I got to get rid of degrees, so I put degrees on the bottom, and get to radians. So as I said before, I'm going to do all of my work in exact form first without any rounding, and then I'll go back and round at the end. So I'm going to divide 125 and 180 by 5 and say that's the same thing as 25 degrees. And 180 degrees divided by 5 is the same thing as 36. My degrees cancel. So now multiplying straight across, I get 25 pi over 36. Give myself a little more room here. So now I can go ahead and say that S is equal to my R, which I found to be 7, times 25 pi over 36. Multiplying straight across, I get 175 pi over 36. Again, rounding to the nearest tenth with my calculator. This is approximately 15.3, and my unit from my diameter, or my radius, carries through, giving me about 15.3 centimeters. So I am doing my rounding at the very end. I could have, of course, done my rounding here and said 125 times pi divided by 180 is approximately, and gone through. I will point out if regardless of what you're asked to round to, if at any point you're rounding in your in-between steps, for example, finding theta would be an in-between step, you must go to 3 decimal places. So you can either wait to round at the end and go to the specified place value, or you need to go 3 place values every time you round in between. If I notice in your work that you're not rounding to 3 decimal places and you're in between steps, I will take points off. Looking at the last piece of information from this video, it's the area of a sector. It is another formula you will be responsible for knowing, so you'll need to know the formula for arc length as well as area of a sector. And it is going to be 1/2 r squared times theta. And again, theta is in radians. So if I have this picture here, notice I've shaded in this sector here. So all I'm asked to do is find the area. So I'm going to go ahead and use my area formula, and that tells me I'm going to do 1/2 r squared times theta. Well, I can find my r by taking half of my diameter, so r is 5 meters, and I can find my theta by converting degrees to radians with a wonder fraction. I put my degrees on the bottom, and I know there are 180 degrees equivalent to pi radians. Again, I'm going to put all my info in exact form first. So I'm going to reduce 135 and 180. So I first reduce by 5, and I get 27 over 36. I then reduce by 9, and I get 3 and 4, giving me a theta value of 3 pi over 4. And now I'm ready to go ahead and calculate my area. I'm going to have 1/2 times 5 squared times 3 pi over 4. Well, that gives me 25 times 3, which is 75 pi all over 8. I'm going to go ahead and use my calculator to find my approximation. It does not on this one tell me where to round to, so I'm going to go to 3 decimals, and I get 29.452 meters squared. And that is going to be the area of this shaded sector here that has a diameter of 110 and a central angle of 135 degrees, or 3 pi over 4 radians. Please make sure in your notes that you do highlight or mark or asterisk or whatever it is that you do these two formulas, because as I said just a moment ago, you will be responsible for having those memorized and being able to come up with those.